All right, in today's lesson, we are going to solve quadratic equations by graphing. So we've been graphing, but now we're actually going to do something with the graphs, and we're going to solve an equation. So this whole unit, we're going to learn all different ways of solving quadratics. So to find a solution, we're also finding what we call roots and zeros. And essentially, what we're finding are going to be x-intercepts. And the idea is, if I have a quadratic equation, x squared plus 4x minus 5 equals 0, to find the x values when y is 0 is really what we're doing. So just doing just like a little quick sketch here. You've got a parabola where it crosses the x-axis, so this crosses at 1 and negative 5. Those are the solutions for x that make this statement true. They're the values of x where the function is 0. So a lot of parabolas, or a lot of quadratics, I guess, have two solutions because they cross the x-axis twice. But it is possible to just have one solution where the vertex is the only point that it touches. And then what would a no solution be? That would be a parabola, a quadratic, where the parabola never touches the x-axis. So when I say no solution, that would be no real solution. Later on, we're going to find other ways to describe what's happening. But for now, we would just say no solution. Okay, the first example, x squared plus 6x equals negative 8. We want to solve this quadratic. The first thing we want to do is we want it to be set equal to 0. So I'll add 8 to both sides. So x squared plus 6x plus 8 equals 0. And what I'm going to do is graph this quadratic. So let's think about the tools we have learned so far. I'm going to find the axis of symmetry, opposite of b over 2a. So negative 6 over 2 times 1 is negative 3. So I'm going to get that on there, 1, 2, 3. Axis of symmetry here. Let's find the vertex, plug in negative 3. So we'll have 9 minus 18 goes to negative 9, plus 8 goes to negative 1. Let's see, I've got the y-intercept of 8. So I know that it's going to touch the x-axis somewhere here. So if I make an xy table, let's plug in negative 1 and negative 2. So if you plug in negative 1 here and here, I'm going to have 1 minus 6 plus 8, which will be 3. So negative 1, 3 is here. I'm going to reflect that. So if we plug in negative 2 in for x, I'll have 4 minus 12 goes to negative 8 plus 8. Hey, there's a 0. Negative 2, 0. And if I reflect it over, I have negative 4, 0. So I'm going to graph. So this point and this point, when x equals negative 4 and x equals negative 2, those are my solutions to that equation. Okay, let's do one more example. X squared minus 4 equals 3x. First thing, it needs to be set equal to 0, so I'm going to subtract 3x on both sides. So x squared minus 3x minus 4 equals 0. Let's graph this. Let's first find the axis of symmetry, that negative b over 2a. So this goes to positive 3 over 2 times 1. So I'll have a decimal, but it's 1.5, not a big deal. Axis of symmetry here. All right, so 1.5 is in my vertex. If you plug in 1.5 for x here and here, you will get negative 6.25. So I'm going to plot that. 1, 2, 3, 4, 5, 6. We'll go down just a little bit. Let's see. Y-intercept of negative 4. 1, 2, 3, 4. So I can reflect that. Let's see, over 1.5, over 1.5 here. So somewhere over here, I'll probably hit x. Let's make an xy table and see what we find. Okay, so let's see, 1, 2, 3. Let's plug in maybe like 4 and 5 and see what happens. Okay, if we plug in 4, 4 squared is 16, minus 12 is 4 minus 4. Oh, there's my 0 right there. So over 4, 0. And if I reflect that over 1, 2.5, over half, 1, 2, there's my other one. So if I graph this parabola, it crosses at x equals negative 1 and x equals 4. Those are my solutions to the original equation. And let's just kind of go back and check it and make sure what we found makes sense. Okay, so if I plug in negative 1, is negative 1 squared minus 4 the same as 3 times negative 1? Is 1 minus 4 the same thing as negative 3? Yes. Okay, let's plug in 4. So 4 squared minus 4, is that the same as 3 times 4? So 16 minus 4 is 12. Or 16, oops, I didn't write that right. 16 minus 4, does that equal 12? Yes, 12 equals 12. So your solutions can get plugged back into the original to check. So there's your full lesson on solving quadratic equations by graphing. Good luck!